notice, and this is typical copyright. We continue with mathematics syllabus 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The content of the syllabus itself remains unchanged. The two main planned changes are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested using compulsory questions. Schedule of videos. As you already know, these first three sections, all 51 of these videos, have been published on YouTube in their entirety. Please make good use of them. From section 4 and 5 and 6, a few of these videos have been published in their entirety on YouTube. The others are only partially published. We are now at section 7, relations, functions, and graphs. And this is the 21st of 26 videos from this section. After that, of course, we still have to do section 8, geometry and trigonometry, and then section 9, vectors and matrices. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Just a reminder that section 1, number theory and computation, I have divided that into 33 videos, and they are all published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. Another reminder that you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Back to section 1. Some of these videos are even applicable in primary schools that students could use on their own, teachers can use in the inverted classroom, and parents can use these videos to help their children in primary school, even though the parents may think that they don't know enough mathematics. For example, consider this blue box up here. If we expand it, you would see that video 6 says, add, subtract, multiply, and divide whole numbers. Children in grade 1 and grade 2 are doing that work. But notice, in order to do that, there is an earlier video that deals with place values. And then video 7 talks about addition, subtraction, multiplication, and division of decimals. Video 8, addition and subtraction of fractions. And video 9, multiplication and division of fractions, and so on. So quite a lot of the work from section 1 of the CXC syllabus is actually done in primary school, especially grades 4 and 5 and 6. Continuing, section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, measurement. Some of these have been published on YouTube in their entirety. These indicated in yellow here. And the others are only partially published on YouTube. If you need to have full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 5, statistics. Some of these have been published on YouTube in their entirety, as you see here, and the others are only partially published on YouTube. Same principle applies for Section 5 as for Section 4. If you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 6, algebra. These 7 videos have been published on YouTube in their entirety, especially since algebra seems to be a problem area for most learners. And the others are partially published. Again, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 7, relations, functions, and graph. This is where we are right now. And this section consists of 26 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2 to get more practice questions. CSEC recommends these that you see on the right here. From those, I would recommend these last 2 down here. As seen on this slide, this is volume 1 by Raymond Tulsi, Mathematics, a complete course with CXC questions. And this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. As of late 2024, a website with AI interactivity has been made available, free of cost, that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that RSC website looks like. This is the home page. You will have to register first, and of course, subsequent to that, sign in. This is the URL again up here. That URL will be in the description of this video below. Another reminder that this formula sheet that you see on the left here is provided for CSEC math examination papers. It is also included in the syllabus. If, however, you don't have a syllabus, you can find a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer and a little better. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the CSEC math examinations. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are at section 7, relations, functions, and graphs. All 5 of these objectives from this page have been completed. Up to objective 9 from the next page, all of those have been completed. Up to objective 13 from the next page, all of those have been completed. Up to objective 17 from the next page, all of these have been completed. Up to objective 20 from this page, all of these have been completed. So really, we are now here at objective 21. Section 7, objective 21. And we also have objective 22 further down here. And the next page contains the remaining objectives in this section up to objective 26. So as I just pointed out, we have finished objective 20. We have finished up to objective 20 in this section. And these that you see here in yellow have been published from this section in their entirety on YouTube. The others have only been partially published. We are now here, objective 21, video 21. Once this is finished, it will be partially published. An overview of how the videos from this section have been and will be published. As you can see, we are here. These above here have been completed and some published in their entirety, some partially. These below here, we still have 2 more to be published in their entirety and 3 more to be published partially, excluding the one we are doing right now. So as I said, objective 21, and it says, interpret the graph of a quadratic function to determine, and here are the things we have to determine. First of all, we have to talk about some concepts, and then we have to determine some things here as specified by CSEC. So the concept of gradient of a curve at a point, we did that before. We need to talk about tangent, we need to talk about turning points, we need to talk about roots of function. All of those would just be review because we have done them several times so far. And then now we would also have to determine a few things. The interval of the domain for which the elements of a range may be greater than or less than a given point. Also, estimate of the value of the gradient at a given point, and then intercepts of the function. So we will approach this objective this way. We will divide it in part A, where we will review, and we need this review to do the second part, some of the general principles that we already have seen. Concept of gradient of a curve at a point, tangent, turning point, roots of the function. We will review that. And then we will continue with part B. So let's begin with roots of a function. We just did that in the last video. So if you have a graph like this, based on a function, of course, we know that the roots of the function or the equation would be where the graph intersects the x-axis. So that would be here, which is -2, and also over here, which is 2. That's how you derive the root of a function that has been plotted on a graph. And the function here was the function f such that x maps into x squared minus 4. We eventually ended up with y is equal to x squared minus 4. One more example like this, because this is work we just did in the last video. What are the roots of that function? Well, where the graph cuts the x-axis. And that point there is -3, and this one here is 1. And those would be the solution of the equation, the quadratic equation. But this is a solution using a graphical method. And what was it? This was a function, and we eventually ended up with the defining equation as y is equal to -2x squared minus 4x plus 6. And that's it for a review of roots of function using a graph. Recall, the roots can be 2 distinct points, one repeated point where it touches the x-axis, or non-existent if the graph never touches the x-axis. Now let's look at the concept of gradient of a curve at a point. Now, remember, this is review. We have done this work before. We know that the gradient of a straight line graph is the same throughout. So if you look at this straight line graph here, which we will look at just now, and this quadratic graph here, you will notice that the straight line graph, the gradient is the same throughout. Let's plot both of these using the same axis so we could compare. And this is what we get. This is a straight line graph, the one in red, and this is the quadratic function graph, the one in blue. If we were to find the gradient of this red line, by now you know, you get a right triangle, locate 2 points up here and 2 down here, and then get the right triangle, and then calculate y2 minus y1 divided by x2 minus x1, and we get a gradient of 2 for that red line. Now, if I were to ask you, what is the gradient of that blue line? Now, you would need to ask me for the question in order to get the gradient at a point. That blue line has different gradients at different points. Now, we will come back to this diagram after we revisit 2 other concepts about straight line graphs. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. Now let's talk about concept of gradient of a curve at a point. Recall that the sign, whether it's positive, negative, or 0, of the gradient means something. So for example, you will see that this gradient here is negative, this one here is positive, and this one here is actually 0. Normally you wouldn't put 0x, but I put that in so you could see these 3 graphs together, and they look like this. This one, the gradient is positive 2. This one down here, the gradient is negative 2, this green one. This other one here, the gradient is 0. Now, if the sign of a gradient is positive, the graph slants upwards from left to right in direction, like this red line here. As you move from left to right on the graph, the line itself slants upwards. Whenever that happens, the gradient is positive. And of course, the gradient is negative if the graph slants downwards from left to right. So as you move from left to right, look at this line up here. It slants downwards as you move from left to right across this page like that. And then, of course, the gradient is 0 if the graph is horizontal, as in this case here. So we need to bear those in mind as we continue with the rest of this objective. That was the direction of the gradient. Now we are going to talk about the magnitude of the gradient, irrespective of direction, irrespective of sign. Now, the greater the absolute value of a gradient, that is the magnitude alone, irrespective of sign, the steeper the gradient is. Absolute values of gradients can vary from 0, which is horizontal. If you divide 0 by whatever x is, you will get 0. To infinity, if you divide y by x, which now is 0. Now you have seen this before. I will plot all of these on the same axis so we can see this matter here of 0.5, 1, 2, 4, 5, and so on. I want to make a point here. We will plot all of these on the same axis to compare gradients. Note the coefficients in red as I just pointed out. 8, and 15. If we plot all of those on the same axis, we get this. You have seen this before elsewhere. This one, the gradient for this one here is it's not too steep, but it's not too flat either. The gradient for this one is 1. It is less than the one above. The gradient for this one is 4. It is steeper than this one down here. The gradient for this one is 5, and so on. You could see as the gradient increases, the line gets steeper. As the gradient decreases, the line gets less steep. This one here, the gradient is 50, which is the steepest of all the lines there. So the greater the absolute value of the gradient, that is, the greater the magnitude irrespective of sign, the steeper is the gradient. Now, let's get back to this slide here. That review reminds us what the magnitude and direction of a straight line graph mean. And you may be thinking, what does the gradient of a straight line have to do with the gradient of a curve at a point? And the answer to that is the word just below that, which says tangent. This is in the objective. So now we have to learn a little about tangents if we didn't know that before. What do we mean by tangent to a curve? And how is that related to gradient of a curve at a point? So what is a tangent to a curve? A tangent to a curve is a straight line that just touches the curve at a single point, the point of tangency, and has the same slope or gradient as the curve at that exact point, representing the curve's instantaneous direction or rate of change. It forms a right angle at the point of contact with the radius of the circle that the curve is a part of. Just to make sure you understand where we are going with this, if you magnify that point, a very small section on the curve, it will approach, or it will begin to look like the tangent there, like a straight line. Consider that circle there. If we have a tangent at this point, it will form a right angle here with the radius. If you can find the gradient of that tangent, you have just found the instant gradient of the curve at that point. And this is what we are leading up to. So if you could find this gradient here of that angle, if this is the horizontal, this blue line is the horizontal, you find that that green line does not have a very steep gradient. It has a small gradient. But what about if you take a point here, that purple line? It still forms a right angle with the radius, but now note that it is much steeper. So you have a larger or a greater gradient. So let's come back to this. Consider 5 gradients at certain points on this graph. Or let's just consider 5 points. We will name them, well, we will name this point here A. We will name this point here B. This one here C. That one there D. Now consider as you move up from A to B to C to D on the left half of this graph. The gradient is steep and positive to begin with, then it gets less steep until it becomes 0 at D. So if you start out here, very steep and positive. But as you keep going this way, on the graph itself, it gets less steep until you reach D, where the gradient is 0. It's horizontal. But now let's consider E, F, and G down here. Now, on the right side of this graph, as you move down from D to E to F to G, the gradient is 0 to begin with and gets increasingly steep and negative. So now you understand why I had to review this matter of straight line gradient. So what does this mean? Simply, if you take a line like this, parallel to the y-axis, and you drag it across this graph, so as the domain increases from far left to far right, the rate of change, which is the gradient, decreases until it reaches 0 and then begins to increase in the other direction. As I said, if you drag that red line across this page like that, it will cut this graph at various points, indicating that the gradient is gradually decreasing from left to right until it reaches 0, but the gradient is still positive on the left of that y-axis. But then as you come down here, the gradient now begins to be negative, small to begin with, and then it increases and increases until the gradient, which is a rate of change, is great down here. So that was part A, review, prerequisite of some of the principles we have already seen, the concept of gradient of a curve at a point, tangent. Now let's talk about turning points. We already did roots. Turning point or vortex on a quadratic graph, which is a parabola, is where the graph changes direction, where the gradient is 0. From increasing to a maximum on the y-axis, then decreasing, or vice versa, to a minimum. In both cases, the gradient is 0. That is the turning point. So at the turning point, the gradient is 0. Whether it's a maximum point, as you see here, or a minimum point, the gradient is 0. And that should suffice for part A, which was review of the prerequisite that we need to continue with the rest of this objective.